So hi guys, so we shall start with the session today. Today, we are going to see we are going to discuss on the topics that is the hands-on on Spark. So that is the agenda of the Spark. Today's meeting would be what is Spark, features of Spark, and how the Spark is built on Hadoop, and there will be a more that is the hands-on training on Spark would be provided. That is, we will work, and you can see that, and also we'll cover the components of Spark, and there will be a question answers session, and that is the question answers can be asked at final 10 minutes or 15 minutes. So because the sessions will not get interrupted, so that is the question sessions now you can ask in 5 to 10 minutes. So let me invite Dinesh, who will be presenting you the hands-on Spark introduction today, and let me just give to him so he shall proceed with Spark. Thank you.
Hi. Actually, this session was taken earlier, but at that time we didn't take for the hands-on sessions. So most of the people requested for the hands-on. That's what we are continuing the same session. The time we have discussed about everything with the Spark details with the agenda. So we just recall everything and then we'll go with the hands-ons. Okay, just for the few minutes. Okay, these are the agendas. So what is Spark and distributed data parallel processing and why Spark is famous and what are the features will available in that Spark and how Spark executing with the jobs and components of Spark and about RDD and transformations and actions. After that, we will be seeing that transformations and action with hands-on. This is our today agenda. Okay. Distributed data okay, before I will start with what is Spark. Okay, so Spark is a on data parallelization tool. It will be help to making our operation as much as faster with our data sets. That's the main important. Mostly the Spark is following through in-memory operations. So those in-memory operations, how we can efficiently making with our data, that's an important. This Spark will be support for the Scala, Python, R, and Java. Four language will be supported, and exactly Spark means data dependencies. Sorry, Spark dependencies like transformations and action with implicit variable is a Spark context. So that is we have mentioned as a ESC, and component context is a SQL plus or Hive context. So this is the total of Spark. So if anybody is asking you what is Spark, these three is enough. So Spark dependencies plus implicit variable plus component context. So implicit variable means is a Spark context. Whenever you are creating the Spark with your CLI mode at the time, you can see this one Spark context as a SC. So driver will start with the SC only. So that implicit variable will be interact with your data and producing your output. That's the nature of the work with that. Then features is big data analytics. It will be much faster than MapReduce. It's 100x faster with MapReduce and 10x faster with the disk. And the support for the batch processor, interactive process, interactive analytics process, and streaming also is possible. And again, Scala, Java, Python will be supported in R programming languages. And why Spark is famous? Reason is we can loading our data into the disk. So whenever we need to making our operation, we need to go and check the data and loading into the memory and providing the output. If the data set is big, we need to loading our data into the memory and producing the output and store again that output into the disk and retrieving. So this operation will be happen again. So in compare with Hadoop, all over the operations, if you are making with Hadoop, the read and write operation is much costly than other operations. So whenever you are reading the data from the Hadoop or writing the data at the time, it will be taking some impact. For example, if you are reading the data, that's not a problem. You just reading with the approaches of name mode operations. But you are writing the data, what will be happen? The data will be split into three replication factor. So same data will be going to load into the disk again producing the output. So that is one of the problem. you're going with the MapReduce concept. At the time they are using for one intermediate partition barrier, they are retrieving the data and loading on there and making that operation. So each one time the output going to store in the Hadoop and retrieving again from the Hadoop only as an input. So that is the main reason for the delay. But Spark will be provided for the in-memory operation. So in-memory operation, you can doing your data with the memory. Based on the memory, you can retrieving the data as much as faster. Last time I said one example, just reminding you your mobile number. If anybody is asking your mobile number, immediately you can tell to the people. Reason is that mobile number will be stored in your memory. But if they are asking some other mobile number, you need to check with your mobile with contact list. Then only you will be producing that output. So that is the delay. You just compare. Okay, Spark will be working as an in-memory operation like your own details. So that all will be retrieved as much as faster. So, like this, the operations will be doing through Spark. Just recalling this one, Spark history, we are discussing about that. And 2010, it was introduced in US Berkeley, and one by one, 2012, research newspaper was introduced with Matthias Amaria. Uh, and 2013, distributors started with the AASF team, and 2014 onwards, Spark version will be introduced, and after that, data frame, high context, SQL context, everything will be introduced one by one. And 2016, Apache 2.0 version was introduced. That is a very famous to compare with the before 1.x versions. We will discuss what is the main importance will happen with that. Okay. So this is an example, distributed data parallel processing, how it will be retrieving the data. So for example, we have the data, if you are going to identifying from your node, all over the data while retrieving from the distributed table, it's going to check with your hash function to segregating the data and producing the final output without any duplications. So hash function will be applied. So those data we have retrieved from there, we need to loading that information to the memory. So without duplication, we can making our operation with the distribution with the equal parallel processing. So we have heard about it. Fault tolerance console will be satisfied by this only. And Spark, how it will be executing the job. So master is a controlling node. It will be controlling all the slave nodes. Okay, like the same name node and data node operation. Instead of name node and data node, we are saying here is a master and slave. We have a lot of cluster management. We have it mostly Yarn, Mesos, and standalone cluster will be available. So if you are going with Hadoop, they will be mostly suggested for the Yarn only. Yarn will be controlling like same master and slave approaches. So whatever the data you have it, you are making your query with the Spark. That query can be controlled by the master only. That is we have saying like a driver. So the query implementation with the multiple slave to producing the output with the task only. So those tasks how it will be splitted with the multiple node and producing the output. And one more thing, if I return the data from the multiple slave node, those multiple slave node, each one slave node having some memory and code, so the data will be processing on there and producing the final output directly to the driver. So all over the information will be running the memory only, in memory only. And one more topic also will be available, heap memory operation, that is very much faster. We will discuss that in later. This is a Spark architecture. So client, if they are requested any query to that Spark master, it's going to check with the driver, and driver already I said this is a Spark context. So Spark context will be making all the operations based on the driver. So all the okay. So driver can be splitting based on the Spark context to the multiple executor. So executor will be interact with the worker. So a worker will be splitted by the task and producing the output again to the executor. So executor, the final output will be sent to the driver. That's the nature of the job. Spark will be acting like that only. So if you are using that yarn cluster management, what will be happen? The driver will be interact with the name node and making some operation with the yarn as a node manager. So node manager will be controlled by the driver. So all over the node resource manager will be controlled by the driver, and node manager will be followed by the workers, everything through executor. Each one worker will having some operation in parallel operation. So what will be happen, each one worker will having some node manager will be controlling by that application master. So application master will be handle all over the task based on the content and producing the output. That is the nature. Don't confusing more with that. Once again, can you hear? Anybody can you confirm anybody with chat? Can I go next? Soumya, have you heard my voice? Yeah, okay, thanks. Okay, what is driver? Now we will be discuss about it. Okay, so entry point of the Spark will be start with this driver only. Mm,
Hey, hi.
hi.
Yeah, so yes, you're gonna start now?
Yeah, just now I have started. Handson will not started still. Just recall all our components what we have done in last session. Just recalling. After that we will be go with that hands-on. Basic transformation.
Okay, this is my
How will be returning everything.
first session with this.
Yeah,
So it's gonna be from the
that's
starting,
what I
right?
know. Some of the people will come for the first session, so I just go what is Spark entirely for your understanding. Then only I will go for this hands-on. Okay.
Okay, that's great.
Okay, these are all the basics. So last week we have taken one special session for that, but this session is probably will go with hands-on only. But you need to know entirely what is Spark. That's what I'm explaining you again for the short time. Okay.
Okay.
Yeah. Thank you. Spark. Once again, I am showing through. Okay, Spark Shell, if you are making this one, this will be interact with the Scala programming. PySpark will be interact with the Python programming. Spark will be interact with the R programming like that. So Spark hyphen Shell, it will be interact with the Scala programming only. So you can see this one driver how it will be started. So, my cluster is so slow. Wait a second, people. Okay.
Uh,
Yeah. 1 second is running, but I don't know why my cluster is very slow.
hey, hi.
Yeah.
Is this Apache going on?
Yeah. Still, I didn't start my hands
No,
on.
actually, I just joined the session right now. So,
Yeah.
can you give me a short, brief thing of what went just before I joined? Thank you.
I think you missed the session. Okay. This is the agenda with hands-on we will be doing right now. This is our account.
Okay, fine. That's great.
Okay. And
So, we are going to start with what is
theoretically,
Spark.
yeah, what is Spark itself, we have to start and we'll be doing with some hands-on also today.
Okay, that's great. Thank you.
Yeah, 1 second. My cluster is getting slow. Okay, people, I will tell you what's the driver. Okay, with the hands-on. So SC will be start if you are going to start with Spark context. I don't know why it's getting slow. So I would like to showing this what is execute driver, what is execute everything to you. Taking some delay with my cluster, will be showing you shortly. Okay. So okay, we'll be discuss about that. So Spark context will be created. Once the Spark context will be created, then only we can interact with the RDD. So what is RDD? I will tell you later. So RDD will be controlling all over the data based on some execution graph mode. So how we are returning the data, what are the RDD will be transfer based on your requirement and producing the output that you will be going to see here. Split the graph into the stages based on the RDD, based on the transformations and actions. The operation will be split into the stages. So stages will be act as a transformations between the actions. So each one operation will be doing through stages only. Uh, for example, you just converting your data into some other transformation. That time only one small stages will be happen. Once you transfer the data from that one stages to multiple stages, are you making some actions at the time the stages will be moving to the next level of stages. So those transformation will be followed through partitions also. In the Hanson, I will explain everything one by one. Okay, and store the metadata about the RDD and the partitions, everything controlled by the driver. Before I said each one operation will be doing through driver, it will be going to check with the executor. But the executor, if whatever the data is coming as an input, it producing the output only. It won't be interact with the data. What is data also? It won't be knowing anything, just producing the output to driver only. That's the work. Just like a slave, it will be working to the executor. So entirely driver will be only will be control everything. Okay. So in WebUA, how it will be represent everything showing to you. Yeah. I just restart my cluster. Let's see. Next is executor. So executor and driver will be working in the same JVM, which is if you are using standalone mode. If you are going without the standalone mode is a multi-cluster mode, so all the executor will having own JVM to producing the output. But in standalone mode only, the drivers and executor both of them in single JVM to producing the output for your requirement. Uh, so executor will be acting your data with your Hadoop or whatever you are making your loading your data. Just yes. Okay. So that is the nature of executor. So read the data from external sources. Whatever the sources you have it just reading the data and writing the operation. Both of them will be doing through executors only. But it will be controlled by drivers. So driver will be acting as a for context SC and perform all kind of data processing. Whatever you need to changing your data from one transformation to another transformation, and making your operation as a based on the action, that all will be doing through executor only. That command only will be sent to drivers. Next is components of Spark. So you can see in down, okay, Spark core will be available. The Spark core will support for these 4 programming languages: Scala, Java, Python, or programming, and those are all will be interact with the data frames API, data frame API that will be support mostly for the to converting your data into the structured format to producing the output. The reason is whatever you have the input that will be interacted as a structured format to producing the output as a row and column. That's a easy way. Okay. Okay. So data frame API will be interact all over your Spark core to converting your unstructured data into the structure and producing the output. Then what is sorry Spark ecosystem? So what are those ecosystem will be having in Spark? Spark SQL, Spark Streaming, Blink DB, Spark Machine Learning, GraphX, Tachyon. These are all the ecosystem will be available. Spark Streaming is help to converting your data into the structured format and making your query with the SQL component. If you know very well about the SQL, then you will be working with Spark SQL. Is an easy way to retrieving the data. You just converting your table data, whatever you have, just convert your data set into the table format and making the table. You just producing your Spark SQL queries to finding output. That's an easy way to producing that one. Spark SQL is a famous one. Next is Spark Streaming. Spark streaming, we'll be doing 2 types of streaming operation. One is structures streaming process based on the near real time. Another one is real time process streaming operations. So those two we can possible to doing through Spark streaming application. So structured streaming operations, how we can do it? We have the data. So based on the data, if you are making with Spark SQL, it will be completely we are getting by each some period time of interval to the our cluster. At the time we need to making our operation based on the new data. So period of the time whatever the data we have received, based on that we need to producing the output as much as faster. So structured streaming will be possible here. Next is streaming. Whatever the data comes, it's going to load into our Spark core and producing the output. So those also we can do it here, those two also. Blink DB is supporting to finding the data as much as faster. That's the main users to implement with this Blink DB. It producing the output with based on that approximate output only it can be producing. For example, in Google also it will be implemented. Google, if you are using to find any keywords, it's going to check the keyword with whatever that new words will come, producing the output. So what happen? All over the data will be going to identify your cluster. Based on that, you input keyword and find out this keyword will be joined with some other keywords also. So it find all over the operation producing to you. So Blink TV also is performing the same. It's going to identify the data and find producing as much as faster. Um, just searching operations like that you just consider it, but it won't be not exact approximate output, just producing that approximate output only. Next is Spark machine learning. Machine learning libraries will be interact with the Spark, so they have introduced for the Spark machine learning here. GraphX is a graphics databases we have it. So whenever we have the data set, we need to represent with the data. Graph model. GraphX database will be support directly. So Spark will be interact with the graphics databases and producing the output. Next is tachyon. Tachyon is a one special component. That's a tachyon. What will be happen? It going to load all over the data into the memory based on the heap, as I said. So what will be happen? All your data, sorry, all your thread based on the core will be contracted, and core will be active. Just saying to Spark, all drive, sorry, every one driver will interact with the all executor. So all executor having multiple tasks. So the multiple tasks, if it is the same, we don't want to retrieve from Hadoop. So instead of that, we will be retrieving only one data into the memory to our operation. So that's a possible way. So TACAN will be doing such kind only.
Sir, I have a doubt.
Yeah.
Hello.
Yes. Tell me.
Yeah, actually, in machine learning, how can you integrate Java in machine learning format?
Mostly.
It's like, it's in Python. Python is supported, but Java isn't actually supported in machine learning, according to my point of view.
No. Actually, Java also possible to doing your machine learning. Why Python is famous means Python will be support for a lot of the machine learning libraries using that pandas. Um,
Exactly. But what I mean to say is that Java's libraries are not actually suited in Python, isn't it? I mean, in Python coding.
Yes, I have. Actually, Spark or whatever you are creating with the Spark, that will be interacted with machine learning also. Machine learning libraries will be available in Java also, but that's not
Okay.
much good with to compare with Python, because Python will be split based on lot of the libraries. So whenever you need it, SkySpy, lot of the library will be having just retrieving the data from that Python pandas. Pandas is a library form. You just retrieving from there and producing the output. But other things they are not making like that. That's the differences. So that's Python was very famous at the time. Still, the Python is famous for the machine learning to compare with other programming languages. That is the reason is this only one, because the developers will be creating lot of the libraries based on the Python programming only before itself. That's the differences.
Thank you, sir.
Okay. Okay, everything we have discussed, and now we will be discussing about the resource management. So resource management will be interacted with standalone, Yarn, and Mesos, as I said before. So standalone, the drivers and execute both of them in a single. That time is a single JVM that will be controlled by the standalone. So that is called as a standalone. So in single system is enough to making your operation in the standalone mode. One second. Okay. Next, Yarn. Yarn following by the cluster management only. You are knowing very well about the Hadoop. Definitely, you know very well about the Yarn. Yarn means yet another resource negotiator. So it will be controlling by the resource manager and node manager to your input, sorry, your data set and producing the output. Same like it will be acting here. But instead of that, what will be happen? The driver will be acting as a resource manager, and executor will be acting as a node manager. But each one executor will having own JVM. So what will be happen? Each JVM will be acting internally is like a another one yarn concept like that. So at the time, node manager will be controlled by the application master only. So application master will be working as a driver. Whatever the task will be created, that will be controlled by the executors. Like that will be performed if you have going with a large data set at the time. That's the main differences. Next is Mesos. Mesos will be for the beginning of Spark was created by Mesos concept only. Same like that, the Mesos will be interacting with the system, multi-core system, at the same time producing the output. That's it. Nothing more with Mesos. Right now they are implementing the Yarn drive to producing the output, because Spark is mostly interacting with the Hadoop big data concept only. Okay, Spark SQL. So Spark SQL is before it was called as schema or DD, because all over the data set it should be presenting some schemas at the time. So it was called as a schema or DD. So Spark SQL executing the SQL query easily to that your data set. So we just converted in Hanson. I will showing you these are also. So Spark SQL and Hive SQL, both of them you can do it based on the SQL context and Hive context. And another programming language, and data frame is one of the famous one with the Spark SQL. What is the importance with the data frame? I will show you in the next one. So data frame, and next one, next to the data frame is called data set. Data frame will not be untyped safe, but in data set will be safe for, sorry, used for type safe operations also. And all over the schema, if you are not mentioning in the column, automatically it can be identifying as a particular column name by default and producing the output. For example, if you are not mentioning all the column will start with a C of 0, like that it will be started. So column 1, column 2, like that. Internally, automatically it identified and making that operations. This is the Spark architecture. So in the front end, whatever the command or data will be available, that will be interacted with the Spark programming stream SQL or some other components. It's going to check with that logical plan first. So Spark SQL convert into the logical plan. At the time, Catalyst Optimizer, one of the type, will be available, that will be supported. So what will be happen, the Catalyst Optimizer that internally convert and producing that one proper execution plan. If you are having lot data set, you cannot identify how efficiently optimizing your command at the time. So Catalyst Optimizer will be doing that operation instead of you and producing the output. So first you will be getting some logical plan. So logical plan will convert into the proper logical plan with optimized, and then produce sent to the physical plan. So physical plan will be going to check with query engine and producing the output. That's the nature of way. Like that we will be doing here. You can see here. So logical plan will be created and resolved first. After the logical plan was created, then Catalyst Optimizer interact with the optimization rule something and producing some optimized logical plan. After that, optimized logical plan interact with the physical plans. So physical plan executing your query based on the query engine with your RDDs. Whatever you have created the RDD, it will be interact at the time only. This is the nature of the Spark SQL work. Next is Spark streaming. Spark streaming. One second. Yeah, my cluster start. Yeah, you can see here. Okay, Spark Shell, I am implementing that one. You can see this one, Spark Vision we have provided, and Spark Shell you have implemented. So Scala Vision was showing to you. So it was start with the Scala clusters. Oh my God. Okay, Apache. Oh my God. something else. Okay, so Scala version you can see here. So Spark context, Spark context available. You can see here Spark context available as a SC as a master local of multiple. So whatever you have the core, if you are making that master equal to local star means it can be identify all your operations dynamically. So Spark context has converted to the SC and starting your versions and implemented with the Spark SQL with 1. Sorry, Spark with 1.6 version implemented with the SQL context also. So if you want to know this version based on the SC, you can feel this one. So Spark context will be created based as a SC. Then you will be identifying all your basic operations. These are like a driver. So 1.6 is a version you can see here. I will show you later everything one by one. So Spark streaming, it will be support for the continuous streaming of data based on the Kafka, Flume, and HDFS, and Kinesis, and Twitter. These are all the streaming API. Will be interact with our Spark to producing the output as much as faster to SDFS or databases or dashboards, whatever you needed. If you need to load your store your output as a file into SDFS, that will be possible. If you represent the data into the your database directly, that is also possible through Spark. Or you need to retrieve your data as, like a report, that is also dashboard. Some APIs will be available. Whatever. Can you hear my voice? Okay, thanks.
Yes.
Okay. Okay, just recall everything. What is RDD? Resilient distributed dataset is the name is called RDD. So resilient means the data if you are using with your SDFS cluster, automatically it can be identified based on the lineage graph mode. And reproducing the output to getting the final output. For example, if you are making your operation with multiple data set, you cannot retrieve one data set, the final output will be false. So that will not be happen here. What will be happen? The RDD will be going to interact with the replication factor where the data will be available, identifying and making your operation with that and producing the final output. That's the main use for the RDD, resilient. Distributed, equally the data will be distributed to the multiple node and making your operation. Because the same data will be available in 3 replication factors. So we can identify from there based on the executor as a worker and finally producing the output. And data set. So whatever you have the data that is called data set, that should be a records or tuples or whatever your non sorry object also is on kind of the data set. We can making our operation with that also. And in-memory operation we know very well. And lazy operation, whenever you are making your operation with the RDD, just transforming your data with the schema information, it won't be making any operation at that time. Reason is we are following through some in-memory operation. So what will be happening if it is transferred into some other format, all the data will be stored into the memory, that will be occupying the memory spaces. That's what they are not introducing like that. Whenever you need for that action, at the time only it will be making your operation, and at the time only the data will be moving to the memory and producing the output. Until now it won't be doing, just converting your data is as a meta only. At the time it won't be sending anything. So RDD, we need to create the RDD. We have created the RDD by three types. One is parallelized RDD. So parallelized RDD we can create based on the Scala objects like a collections. We have a list, set map, um, tree, list tree, sorted tree, like that. We have a lot of the collection will be available. Based on that we can creating some already. So from that we can convert that already as a requirement, making our operation. Second way is based on the stable storage. So data wherever you are going to store, we just returning the data into the already format and making our operation. Those data will be available in HDFS or AWS or local mode. Whenever wherever it will be available, we just returning the data and making our operation with that. That is also one of the way. Third one is transforming from one RDD to another RDD. So once you load the data into the RDD, you need to convert the data into the another format. That is also possible here. I can show you here in the hands-on itself. Okay. Value of mm, yes equal to parallelize. Just a second. First one. Cache will be. One second. Can you hear my voice first? Cache will be support for the heap memory operation only. Whatever the data you have, it will be support. It will be working as an in-memory operation. But if you are applying as into cache, that time that's going to load into the heap memory operation. So same thread, so multiple thread, we need it should be interact with the same one input. At the time only, you can convert the data into the cache. So all the thread directly going to interact with the cache memory only. Cache memory data only data set only. Instead of it's going to check with multiple. That's the differences. 1 minute. I just prepared a hands-on, but my system is getting slow. Even to LGB. Wait for some time, please. I just restart my cluster and we'll know about it. Can you clear what is the use of cache? Any doubts with that? The cluster is restarted now. Wait for Yeah, that's a yeah. K means that's a heap memory. That's the differences. Heap memory overhead is another one also will be available, but this time it's not confusing anymore. So cache will be stored in the heap memory. If you're applying this is dot cache, because all the data will be going to the RAM, then only will be starting that operation. That is in-memory operation. Why we need to specifically mention the cache at the time the cache, all the data will be converted into the heap memory. That is very easy to interact with our JVM. That's the main thing. JVM between the CPU. That's the main differences with it. But depend upon the size also. If we have less memory, RAM memory at the time, if we are going to apply with the cache, the data set will not be sufficient with that your in memory, sorry, your RAM memory. At the time, the cache will not be performing better. That's where persistence is another one concept they have implemented. So if the data set, you know very well, this data set will be compatible with your RAM, we can do it. At the same time, we need to identify the memory, the RAM memory will be occupied with some other application at the time or not like that. Before we need to ensure, then only we will be starting our option with cache memory. So these are all some importance we need to check with that. I hope this time is okay. Okay, we will be going to create one already now. Let's see dot parallelize is a full meaning. If you have if you are not fulfilled with that spelling, just give the tab after parallel space, after that para, enter that one, automatically it will be producing that one. I'm creating one collections based on the array. Now the RDD going to load that array value A, B, C into that. RDD is the name. RDD is a RDD name. Just give enter. You can see this one. So this is a parallel collection RDD because you're just loading your data based on that parallel collections one. You can see here. This is a parallel collection RDD. So parallelized, you just loading your collection object into the RDD. That's what was created like that. I'm applying to mapping now. Value of y equal to x dot set equal to set comma 1 RDD dot. Now it was converted into the map partition RDD. Now you can feel the differences. RDD dot collect to retrieve the data. A, B, C is the array of the value. It will be loaded into the RDD. It just transform into another format as a map operation. In map operation, I mentioned just loading the data based on the whatever the data comes is a data will be that word, the first record will be having a key and producing one value as a 1 to every each one. So here it will be happen A comma 1, B comma 1, C comma 1 like that. And this is called map partition already because mapping function you just applied and convert into the map function at the time. Can you clear? Okay, next. Next way is value of load the data from stable storage. So from the storage spaces, you need to load your data into the RDD. That is possible. We can do it now. Value of RDD equal to sc dot text file. I think I am having some data into the use case memory. Example word count is a program name. questions. Why map is not returning a type of map instead of it is array. Map will be represented as a map partitions only. This map is a collection. We just convert into that map operation. So key and value will be applied to the type is array collections only. So that is you can see this one. I will show you that one also. I will show you that one. Why it's converted to the array. You can see here the map definition will be interacted with that implicit scalar reflect in the class tag. Whatever the class will be represented, it convert into the same class tag. That's what is producing that array operations. Okay. Value of okay. I'm doing next operation. The system is slow, so I will do it one by one faster. Already c dot text right. Cloud egwo.txt I think. Already dot I can retrieve my data. This is the path home cloudra eg word count example.txt. I just loaded there. Just I loading the data into the RDD and retrieving here. So that is also possible way. Third one is transforming an RDD, existing RDD to new RDD. That is before also we have done value of y equal to we have loaded some RDD and changing some operation to that. Here also we can do it. You can see here. I will do it my examples faster. Finally, I will explain all your questions. Because my cluster is getting slow due to some memory operation. At the last, I will explain all your questions. Okay, please put them. RDD1 equal to RDD dot count output. So value of 4 is the output based on that RDD. RDD total output I just loaded into the new RDD. If needed, you just convert the data into the flat map operation to split your data. That is also possible. We can do it everything. Just understand what I'm doing here. Okay. So RDD1 dot Sorry, RDD is a value. So directly we can identify the data. If that object belongs to the object, then only will we go for collect, take, show like that. That's the main differences. Okay, this is a. I think people will be clear. If any doubt, you can come back to me. And finally, I will do it all the operations, transformations, and action. You can feel this one. This is a Spark job. Whatever you are doing the operation, going to making in this web UI 4040 is a web UI spaces. There, all the information will be tracked based on the jobs and stages and storage and environment executor like that. So I was doing some operations. For your references, I'm taking with the 234 of task I was taken. Within a 3 seconds, I'm producing the output. For your references, I'm just taking this one. The data was, this is a select number of record is 3.7 billions of record. I was retrieved uh, with 34 stages, 34 partitions, and producing the output within a 2.88 seconds, not minutes. So Spark will be support to making that operation as much as possible. Here 3.7 billion records, if you're going to check with the RDB it's taking long time, but in Spark within a 2.8 second you can identify the data entirely. That is also one of the possible. Uh, Spark is how it will be efficiently. I was working with a standalone only, not in multi-cluster mode. Multi-cluster mode, I am working with the 300 billions of record. That was also very fast to retrieve the data. Transformations and action. Transformations and action simply identifying if you are getting any new RDD in the return, that is called transformation. If you are not getting that new RDD in the return mode, that is not a transformation, that is called action. That is the main differences. Don't confusing mode this time. We have discussed those are all in the before itself, and these are all some transformation: map filter, flat map partition, group by, sort by. These are all, and actions are reduce, collect, aggregate, fold, first, take, for each. Those are all the action. You can feel the differences if you're converting one RDD to another RDD. So map, flat map, filter, that data will be converted and producing a new split operate. Sorry, new transformation output. That is transformed output. That is called transformation. But these are all count operation or collect, aggregate. These are all be joined, combined, and producing the final output only. Just how many data will be available in that particular RDD you can identify. So these are all working as a mapper operation. Action will be working as a reducer operation in what is that? A map this concept for your understanding. I will do one by one right now. Please understand. I will do it all the operation. Then finally, I will explain all your questions. You just typed now. That's not a problem. I will do it my operation with the cluster. After that, I will explain. Map operation we have seen. Next is filter operation. We can fill here. So value of already data will be available. I think. So this is the data. Not required. I just convert the data. This is the value. Now I'm using for transformation filter or transformation. RDD that for your understanding RDD1 RDD new is enough. Dot filter based on the filter splitting the data. So modulo I just applied there and getting that output, and the modulo will be equal to that one. Then we will be doing two, three. For example, we have some array value 1, 2, 3, 4, 5, 6. We are modeling the data based by 2. If we are getting that outcome is 1, that data only will be loading to the RDD new. If the outcome will not be equal to 1, that data will not be loaded. So that's the differences. RDD dot RDD1, RDD1, 2, 3, 4, 6, RDD data will be loaded. Can you hear my voice? Okay, thanks. So RDD is a data value. I just loaded 1, 2, 3, 4, 5, 6. So direct RDD output array 1, 2, 3, 4, 5, 6. So just implementing comma here and just showing you the same output. I didn't convert any data still based on the filters. Now I applied further filter operation here. RDD.filter this operation. Now I just returning the data. You can feel this one. Whatever the data will be divided by 2 and that modulo value equal to 1, that only will be filtered and stored into the new RDD number. You can see this one 1, 3, 5. That only will be divided by 2 and the output will come with 1. 2, 4, 6. Those all will be divided by modulo by 2. We are getting the output as 0 only, so that will not be represented here. That's the differences. So filter function will be working like that. This is the command. This is the command before I was applied. Now you are clear, I think. Like that it will go for me. Next, flat map we will see about it. So flat map, mostly vertical programming, a lot of the time you can see this one. So based on the flat map, the data will be splitted. So data will be transformed from one format to another format. So flat map, if you are going to apply those data split into the many one to many operation, you can see this one now. The word from okay. Flat map output equal to RDD dot flat map flat map of splitting the word count as a data value. Split now. I'm producing word word split by spaces. I'm getting the output. Now you can see this one rdd.collect. The output is hi, I'm Dinesh. Hi, I'm Sasi. Hi, thanks for Spark. That's it. I'm applying that this RDD value into that flat map value as a fm dot collect. You can see this one. Each one will be splitted. Hi, comma, hi, comma, a, comma, m, comma, like that. It will be splitted. Like the sorry, like that. It was splitted now. The real data will be available like that. Based on the spaces, I just split all the data, sorry, all the words and producing the output. So flat map will be supported to transform the data from one to many operations. Next, group by operation, we will be see about it. Value of A equal to C dot parallelize array of Spark scalar Spark scalar Hadoop in SQL. These are all the word. I am producing that value of A is a one of the already parallel collection mode. I just loading this object to that A. Now based on the group by, I just getting the output value of B equal to A dot group. B is a caps letter, so group by word of here I am grouping the data based on the first capital letter, not a capital letter, first letter. So I am applying for new command is caret is the one of the function. So based on that, 0 is an array variable of first letter. So for each one, the word of first letter can be identified based on the it is going to grouping now. Now I am returning the data. Now you can see this one. So first letter compact buffer will be applied. So buffer the data will be splitted grouped by the each one first letters. H is the first letter for the Hadoop and I. It combined grouped to one thing, and next one is capital S is another one group function. Based on the character art can be identified. Based on the it will be grouped. So Spark, Scala, SQL, everything will be grouped by that S letters. Okay, this is the group by. Now we will see about group by key. what is the difference between these two. Okay, so group by key, if you need to apply at the time, you need to know that map function. So each one, whatever that map function you apply based on the key and value, those only you can apply for group by key values. Here we have Spark, Scala, everything only. If we need to apply the group by key function, we need to convert the data into the key value first, then only we can do it. So value of a map equal to a dot map, each word grouped by, sorry, value was produced by 1. This is the a map value. Now the value was applied. Spark, Scala, Hadoop, everything was key as value like that. So Spark is a key value, key, and 1 is a value. Each one I just loaded like that. Now going to apply the group by key here. Value of group by key equal to a map dot group by key. I think stats. It's a string value. A map is a group by collections. Map partition already was applied. Partition already dot. The data was map partition was applied. Okay, we will create new one. Okay. Array of already too many arguments for method parallel sequence. Always array of okay. 1, 2, 3, 4, 5. Parallelize 1, 2, 3, 4, 5. Okay. The parallel connection was created. Okay, so this is a low version 1.6. 1.6 will be applied for group by only. After 2.0 version only support for group by key function also. So all key function will be supported by after 2.x versions. 1.6 will be support only for group by. I forgot it. That's why I'm confused. Let's see one second. I will check it out one more time. B, 4, E, 10, C, 20, A, 15, E. So group by function, group by only will be available. I'm sure group by key will not be available here. So I will tell you later. Union, okay, union will be available. We will be working for union now. So A data already will be loaded here. So A information is B, 4, A, 10 is our A collection value. Going to apply with another one union value. Just connecting both of them. So C value is, let's say this one. All the data will be combined together and producing to you. Before it was loaded this 4 only. B already we have loaded these 3 data. If you are applying the union, all the data will be joined together and totally 7 elements it can be produced here. So that's the differences. Next we will be check with the joins operations. So joins operation same like that, equal to A dot join B join dot. So whatever the data will be having further key is a key A, it will be interacted with the other tools also. This is like a join operation. We need to do it. Next, we'll reduce our operations. We'll be seeing as like actions. Action equal to, let's see the parallelize array. So just converting the data into the reducing option. Action dot reduce. I am providing two input variable like x comma y equal to x plus y. Value of action underscore output. So you can see here that the total output. So what happened? It's going to count all the data one by one, 1 plus 2 plus 3 plus 4 plus like that, based on the reduce operation, converting the data. So you provided 8 elements here. The action convert all the data based on your functional operations and producing a single element output. So it won't be written as already written as of values types. Only it can be written. That's the differences. So in transformation, all the operation just converted one transformation to another transformation, flat map everything. Based on that, you will be applying some operations. But in action, whatever the data you provided, it won't be converted into the new transformations. It joins based on your requirement. It's going to note, sorry, counting that, not counting, making some computation operation and producing only the output. So whatever the data will be available, based on the output only you will be returning. This is not a transformation. Getting that output, sorry, actions operations only. So action underscore is 36 is the output. That only going to load into that your variable name. That's the differences. Now you'll be see that pin max value. Aggregate function I'm going to apply here. Value of maximum equal to action dot max. So maximum value is 8. Mm, 20. So it can be identifying until your 9 elements, identifying all the elements and producing only one final output. So aggregation operation maximum I applied in here to identifying which is the maximum number of the particular RDD values. So these are all the basics. In Spark SQL, we will be converting now. Now we will see about the Spark SQL. Data frame I'm going to create. SQL context. Read dot format. I'm implementing some data into pocket file format. Load your data into file. Pocket file. First I need to check it out where the data will go. I think this will be available in use case slash airlines slash pocket underscore new folder in Hadoop, but not sure. Let me check it out. SQL context read dot file. Airlines pocket underscore new. Okay. Use case slash use case airlines SQL context read format pocket dot options header row dot option info schema to scala overload method values options alternatives. Okay, option SQL context dot read dot pocket option header true schema true file table header. I will do one thing. Data frame underscore new go to SQL context dot read dot table use case dot Lines is a table name. df dot print schema df underscore new. Okay, now I'm loading all the data from directly from Hive tables. The Hive table name is airlines. From that, I'm loading data into the df underscore new is already. I just loading that. On print schema, I just verified all the data will be loaded properly or not, like that. Df underscore new is also already name, which was loaded. These are all the data will be available. So df dot show all the data we can retrieve here. So almost it is having 22 years of data. Before I showing to you 1.2 billions of records, it will be loaded. So based on that, we will be doing our operation. This is directly if we are going to load the data from table, like that we can do it. Another one is the table data will be available in that SDF file only. So based on the file, we can retrieve the data. That is also one of the one of the way we can do. Okay, this is one thing. Now I will try for that another one operation. Why it was not accept? Format pocket options headed true option info schema true load a file use case. I'm getting the spaces. Deploy mode. Okay. Read dot pocket will be available. Okay, pocket. I'm loading the data here. Data is converted and loaded from the directly pocket file, just loaded here and making my operation. Before I was doing the same operation with the tables. Now I was doing the same operation based on the files. Just feel the differences. Okay, this is the before command. So based on the table SQL context dot read dot table of the table name, I just loading the data from the table directly and making my operation. This is another one way. Based on the all the table data will be available in HDFS because the HDFS is following through file directory only. So the file I just loaded here. Two kind of operation I'm doing. Now I'm returning the data df dot show. Same data will be retrieved. The total count value is for the file is 2.8 billions of record I was loaded there. 36, yeah, 2.8 billions of records. So this is the total value. So I'm doing some operations based on the count using the SQL context here, like SQL query as I said before. So what I want to do, just loading the data frame into the table format. Registering table now into TBL airlines databases, this one. Now the data is converted, that data frame is converted into the table underscore airlines is a table name, like that. Now I can applying my query directly. SQL context dot SQL select year comma count of the total data each year, how many data will be available. We are going to checking now from TBL underscore airlines group by year, order by year. Almost 200 task was run and taking the output entirely. This was taking for only 4 years of data, 2.8 billions of records. But this we have for 22 years of data totally. This is only taking for 4 years data sample. This is the command we can doing this operation. You can see this one that output. This is a job. Whatever you are doing the operation, here you can see this one based on the job IDs and open that one. Checking the DAG operations also, how the DAG will be represented here. So tungsten engine I was executed backend. So tungsten engine will be acting into the multiple stages. So one stages will be making the output. That output has transformed to the next stage as input and producing the final output. Like that it will be performing. So totally 200 tasks will be running, but within a 2 seconds we can retrieve all over the data. So that's the main thing. So first stage is 200 tasks within a 2 seconds producing the output. 4 tasks will be representing within a 3 seconds. Total 5 seconds to understanding your entire cluster, sorry, your entire data set. The data set value is 2.58 billions of records. 2.8 million, I think so. So if you are doing the same option with the RDBMS or other tool, definitely it will take minimum 10 minutes or 5 minutes. Year of, first I need to know what is the format. What are the column will be available. So year, month will be available, date of month, those are all the column will be available. So based on that I'm converting to, I'm making some queries. So month, comma, count of the total data I'm retrieving here. Group by year, comma, month. Or order by year, comma, month. I'm showing minimum 300 records. Now first stage will be running in the backend. The next stage was running again. So each month, each year, how many data will be available for the particular month? It identifying here. Year wise, month of total number of records will be available. Just retrieving the data now. Here also you can see this one job. This is a new job number. So within a 4 seconds we can retrieve all the data. 200 tasks will run in within a 1 seconds. So shuffle read will be 14.2 KB only read. The reason is all over the data will be loaded into the in-memory. That's what it was taking this much as fast to compare with other things. Any doubts with that? Now you can ask me any doubts. I think this is enough. People, any doubts? stored in cache. Okay, I explained this one. Is Spark context is an entry point? Yeah, Spark context is an entry point that will be acting as a driver. Okay, why map is not returning a type? I explained everything before. Can we integrate with Spark